This is the second in a two-part naming review. We're going to talk about how to name covalent compounds and how to name acids. Remember, the first thing you have to do when you're naming something is to figure out the type of compound. If you don't know the type of compound, you cannot name it. The rules are different for different types of compounds. So, how do we identify a compound? First of all, does it have a charge? If it has a charge, it's an ion. If you want to know how to name ions, go to the other lecture. Is there a metal or ammonium in front? If there is, then it's an ionic compound. If there's a nonmetal in front, then it's a molecular compound, and if there's a hydrogen in front, it's an acid. And that's what we're going to look at in this lecture. We're going to look at molecular compounds and acids. We'll start by naming covalent compounds. The element that's to the left on the periodic table or underneath in the same group comes first, and it keeps its name. The first element has a prefix only if there is more than one atom, and the second element has a prefix for however many there are, and it has the IDE suffix, so you drop the name ending and add IDE. Here's a table of prefixes, and this table is on Blackboard. Remember, these go only with molecular compounds. Ionic compounds do not get these prefixes. Some examples: we have sulfur and we have 3 oxygens. This is a covalent compound because the first element is sulfur, which is a nonmetal, and it's not hydrogen. There's 1 sulfur, there's 3 oxygens, so this is sulfur trioxide. Second compound, we've got nitrogen and oxygen. There are 2 nitrogens, so that has the prefix di. There are 4 oxygens, so that has the prefix tetra. And the oxygen drops its name ending and gets IDE. So this would be dinitrogen tetraoxide, which is sometimes written as dinitrogen tetroxide, leaving off the A. Carbon monoxide. There's 1 carbon, there's 1 oxygen. The oxygen drops its name ending, gets ide oxide, and there's 1 of them, so it's carbon monoxide. Since the first element only has 1, we don't put the mono. It would not be monocarbon monoxide. The fourth compound, we have phosphorus, and there's 1 of them. We have 5 fluorines, so that is phosphorus pentafluoride. Remember, molecular compounds don't have a charge. There are no ions. Don't try to balance any charges. Don't try to do anything that you do with ionic compounds because there are no ions. There is no charge. All right, let's look at naming acids. When you're naming acids, the name of the acid depends on the name of the anion. And you need to remember this. Repeat this over and over and over to yourself. The name of the acid depends on the name of the anion. So you must know the names of the polyatomic ions. If you don't know the name of the anion, you're not going to know the name of the acid. And if you need help with that, go back to the other lecture. If the anion ends in ate, then the name of the acid ends in ic. So for example, chlorate becomes chloric acid. Ate becomes ic. Chlorate becomes chloric acid. Perchlorate, ClO4-, you put a hydrogen on it so that it's a neutral compound. It's now an acid, and it becomes perchloric acid. Sulfate, SO4 2-, you put 2 hydrogens on it, and now it's a neutral compound. It's an acid, and that is sulfuric acid. So sulfate becomes sulfuric acid. By the way, if we only had 1 hydrogen on there, it would be HSO4-, and that would be hydrogen sulfate. Nitrate, NO3-, put a hydrogen on it. It's a neutral compound, and it becomes nitric acid. If the anion ends in ite, ITE, the name of the acid ends in OUS. So chlorite, ClO2-, becomes chlorous acid. Hypochlorite, there should be a minus there, ClO-, becomes hypochlorous acid. Sulfite, SO3 2-, becomes sulfurous acid, and nitrite, NO2-, becomes nitrous acid. So if the anion ends in ite, the name of the acid ends in us, O-U-S. If the anion ends in ide, IDE, the name of the acid begins with hydro and ends with ic. So chloride becomes hydrochloric acid. Cl-, put a hydrogen in front, so you get HCl and you get hydrochloric acid. Sulfide becomes hydrosulfuric acid. Fluoride becomes hydrofluoric acid. And cyanide becomes hydrocyanic acid. So here's a flow chart. The anion ends in IDE. The acid name is whatever it is, ic acid. Chloride becomes hydrochloric acid. If the anion ends in ate, then the acid ends in ic. So chlorate becomes chloric acid. If the anion ends in ite, then the acid name ends in us acid. So chlorite becomes chlorous acid. Notice there's only three possibilities. We have ic acid, we have us acid, and we have hydroic acid. So even though it seems very complex, it's really not. Only three possibilities. Ic acid, chloric acid, us acid like nitrous acid, and hydroic acid like hydrobromic acid. And here are three terms that may confuse you. Hydrogen is a name added to an anion that has one or more hydrogens in front, but it still has a charge. It's not an acid, it's an anion. Hypo is a prefix for a polyatomic ion that has one less oxygen than the ite form, and hydro is a prefix for an acid whose anion name ended with IDE. So our examples: hydrogen, here's hydrogen sulfate. Hypo, we have hypochlorite. And hydro, we have hydrochloric acid.